Welcome, this is Amanda Rackinson-Zapke, and in this tutorial I will be discussing with you hypotheses and hypothesis testing. We will look at a definition for hypotheses and look how to write different hypotheses. We will then talk about hypothesis testing, and we'll look at the different steps, including stating the null hypothesis, choosing a statistical significance level, carrying out the appropriate statistic, and making a decision regarding that statistic. We'll also talk about type 1 and type 2 errors. Let's start by talking about a hypothesis and defining it. In order to establish whether a theory has the capability to describe, to explain, or to predict a behavior in the real world, it's necessary to construct tests of inference arising from that theory. Inferences are generally expressed at a conceptual level. For example, we might say experienced educators are better teachers. However, in order to actually perform tests, it becomes necessary for us to express these in operational terms or express them as hypotheses. For example, we may take the inference experienced educators are better teachers and put it in operational terms and say that the proportion of educators who are evaluated as outstanding by a panel of experts is highly related to their number of years teaching. Now, a hypothesis then is an educated guess. It can be supported or refuted through or by experimentation or observation. Another way of defining hypothesis is a statement about a future event, or an event the outcome of which is unknown at the time of the prediction, set forth in such a way that it can either be rejected or not rejected. Now, if a hypothesis is supported, evidence exists that supports the theory. If the hypothesis is refuted, then this theory is not supported. As findings support hypotheses related to a theory, the theory gains trustworthiness. For example, Null's adult learning theory has been tested, and the inference adult learners are independent and self-directed has been supported through multiple observations, through multiple experiments. As such, adult educators trust this theory and they therefore apply it. Some adult educators will ask students even to formulate their own learning objectives during the first week of the course and encourage independence, which encourages independence, and adult students control then their own learning. So, a hypothesis is a statement about a future event or an event, the outcome of which is unknown at the time, that is set forth in such a way that can be rejected or not rejected. And whenever there's support for a theory around or support for a hypothesis around a theory, that theory gains trustworthiness, and when it's considered trustworthy, then practitioners often apply it. Now, a hypothesis, remember, a statement about a future event, is stated in two ways for a research study. It's stated as a null and an alternative or research hypothesis. A null hypothesis states that there's no relationship or no difference that exists between variables under study, whereas an alternative or research hypothesis states that there is a clear relationship or difference among or between variables. Now, every research question has at least one null hypothesis and one research hypothesis. The research hypothesis can be stated in one of two ways. It can be stated as a directional hypothesis or a non-directional hypothesis. A directional hypothesis specifies the direction of an expected relationship, and it indicates that the researcher plans to do a one-tailed analysis or test. A non-directional research hypothesis does not specify the direction of the expected relationship and therefore indicates that the researcher plans to do a two-tailed test. For example, a directional hypothesis may state that a researcher expects a positive relationship between two variables or an increase in students' scores from pre-test to post-test, whereas a non-directional hypothesis would state that the researcher expects that there's a relationship between variables or that a difference will exist in test scores between the pre-test and post-test. Now that we understand what a hypothesis is, there's two more related terms that are important to understand. The first is a statistical hypothesis. A statistical hypothesis is a claim about a population that can be tested with data obtained from a sample, that is, only a portion of the population. Oftentimes, researchers want to understand the population, but they only have access to a small portion of it, a sample of it. So oftentimes what happens is that researchers collect data from the sample and do statistical tests. The second term that it's important for us to understand is a hypothesis test, sometimes also called statistical significance tests. A hypothesis test is an inferential statistic procedure in which the researcher seeks to determine how likely it is the results of a study are due to chance. In other words, the researcher is trying to determine whether or not to attribute the results observed to either sampling error or the actual relationship or difference between the variables being studied. Now, when I say sampling error, what I mean is chance, the possibility that chance affected the covariation among variables in the sample statistic. In hypothesis testing, the researcher decides whether or not to reject or fail to reject the null hypothesis. Now we're going to take an in-depth look at hypothesis testing in this tutorial. However, before we go on to discuss hypothesis testing, let me stop for a moment to review the difference between a population and a sample. It's really important that you understand the differences between these terms as well as the notations used for each. First of all, let's talk about population. The population is all the members of a group that a researcher plans to focus on. It's the focus of the research. Sometimes populations are very large, and the researcher can't collect or doesn't want to collect data from everyone in the population. So the data is collected or information is collected from the sample, and a sample is a smaller group that represents the population. The overall purpose, remember, of research is the generalization of results to a population from a smaller sample that's taken from that population. We generally assume that our sample of, as you can see, n, is randomly selected from our population of n, and that the population is normally distributed. Now, these assumptions need to be checked in any design. Even when samples are random, and sometimes they aren't, we cannot guarantee the sample characteristics will be identical to the population characteristics. And this discrepancy is what we call sampling error. Now, all hypothesis tests have unavoidable, quantifiable risks of making the wrong conclusion. Statistical tests, in other words, always involve type 1 or type 2 risks or errors, which we'll discuss later on. However, here it's important to understand that research is done with a sample taken from a population. Now, while we're talking about samples versus populations, something else I want to note here is that the scientific notations for mean and standard deviation are represented with different symbols. So when you see different statistical formulas with these different symbols, you can note whether or not it's the statistical formula for the population or for the sample. So here I've noted those on the slide. You can see the scientific notation for population and sample for the mean, and then also for the standard deviation. So now that we understand the difference between populations and samples, let's go ahead and move on to hypothesis testing. There are 4 primary steps to hypothesis testing. First of all, the researcher states the null in the research hypothesis or hypotheses. They choose a statistical significance level, they carry out the appropriate statistical procedure, and then finally make a decision regarding the hypothesis. Let's take a closer look at the first step, stating the null in research hypothesis or hypotheses. As I said, the goal of hypothesis testing is to see if there is sufficient statistical evidence to reject a presumed null hypothesis in favor of the alternative hypothesis or research hypothesis. Therefore, the purpose of any inferential statistic is to determine if there is sufficient evidence to reject the null. So the very first step of hypothesis testing is to state what we're studying. It's to state or specify the null hypothesis and the alternative hypothesis. It's important to note that these hypotheses are derived from the research question, which are ultimately derived from the literature. So the literature drives the research question, and then the research question then guides the statement of both the null hypothesis and the research hypothesis. These hypotheses can be written in either words or in symbols. For the most part, for social sciences and social science research, words are expected. However, they can also be stated using symbols, and we're going to take a look at that. Here you can see how the null hypothesis as well as the alternative hypothesis can be stated using either words or symbols. Let's take a closer look first at the null hypothesis. Remember that the null hypothesis assumes or states that there's no statistically significant difference or relationship between certain population values. So, if a researcher was writing the null hypothesis in using words, he or she may use terms or words such as there will be no effect or no difference. The researcher in conducting a correlational study may say there's no relationship. Now I'll bring attention here to the symbols used for the null hypothesis. Here you can see that symbols used for difference are different than that used for relationship. For relationship, R or rho is the symbol used, not the P. And rho equals the or represents the relationship or strength of the relationship. And here you can see rho is equal to 0, meaning there'll be no relationship. For the alternative hypothesis, which assumes or states that there will be a statistically significant difference or relationship between these population values being studied, the researcher uses terms such as there will be a statistically significant difference or a statistically significant relationship if he or she's writing the alternative hypothesis using words. And then here you can also see the symbols used for the null or for the alternative hypothesis. Now you remember that a research or alternative hypothesis can either be proposed directionally or non-directionally. And this then determines the type of terminology used or symbols used when stating the research or alternative hypothesis. If the researcher desires to state a directional hypothesis because he or she has strong empirical or theoretical support for doing this, he or she will use terms such as increase, decrease, or positive relationship or negative relationship and use the corresponding symbols shown here. However, if the researcher plans to state a non-directional hypothesis, which is the type of research hypothesis that's usually used, the researcher will use terms or words such as effect, difference, or relationship and use these symbols listed here. While we're talking about stating hypotheses in words, I want to take a few minutes and talk about precise terminology. Although not all researchers would agree with this as they use terminology interchangeably, some researchers suggest that the terms that are used in a hypothesis and research questions imply specific research designs and statistical analyses that are going to be used in the study. Therefore, I would agree with these researchers and say that it is important that you use precise terminology. Let's take a closer look at this. Let's say that you state a null hypothesis of there will be no significant relationship between variables. Now, what design looks at relationship between variables? A correlational design. So if the word relationship is used in a hypothesis, this implies that you're looking for a relationship and will likely use a correlational analysis or a correlational research design and the corresponding correlational analysis. Now let's look at the word effect. Let's say as a researcher you state that there will be no effect of a specific intervention on students' achievement. That's your null hypothesis. Now, what research designs look for an effect? Well, if you remember, a true experimental and a quasi-experimental designs look for an effect between of an intervention. So chances are that you will, if you use the word effect, you are going to do a quasi-experimental design or a true experimental design. And because these two designs look at the differences between groups or within groups, you'll most likely do some type of group comparison analysis or difference analysis. Finally, we have the word difference. Let's say as a researcher you say that you are looking for a statistic, or you are looking to see or test the null hypothesis that there is no statistically significant difference between two groups, and you're looking to make sure that there's no statistically significant difference in their academic achievement. One group, let's say, gets the intervention and one group doesn't. What designs look at differences? Well, we just talked about two, the quasi-experimental design and the true experimental design, right? And so difference could imply a quasi-experimental design or a true experimental design. It could also imply one other group comparison study. It could imply a causal comparative design. Remember, a causal comparative design can't look for a cause and effect relationship, but it can look for a possible cause and effect relationship. So oftentimes researchers will use the word difference in their research questions and hypotheses when they're using a causal comparative design. Now note here, the word effect should never be used when talking about a causal comparative design, because you can never determine cause and effect relationship in a causal comparative design. You can only look at possible cause and effect. So let's consider one more example. Let's consider that you as a researcher pose the question, is there a difference in university students' perceived learning based on the type of course in which they participate, either online or residential? What design, first of all, research design, does this question imply? It could imply a true experimental design or a quasi-experimental design. It can also imply, remember, a causal comparative design. And finally, it also implies what type of analysis? Well, it's looking at the differences between two groups, and that's clearly stated on one type of or on one dependent variable. So this implies some type of analysis of difference, and in this case, an independent t-test. Let's look at one more question, because it's very important that you understand precise terminology and use precise terminology. What if you as a researcher pose the question or the hypothesis? Let's look at hypothesis in this case, a null hypothesis. You're going to test the null hypothesis. You're going to test the null hypothesis that there will be no statistically significant relationship between university students' perceived learning scores and their sense of community scores. What, first of all, research design does this imply? Remember, you're looking at relationship. It implies a correlational research design. And then what type of analysis does this null hypothesis imply? A correlational analysis. And since you have two scores, maybe at ratio and interval level, it implies that the researcher, or you in this case, plan to do a Pearson's R. Okay, now we know that the first step in hypothesis testing is to state the null hypothesis. And in social science, we usually do this in words. And we've talked a little bit about how to do this in words. But now we're going to take an even closer look at how to write an effective hypothesis, both a null hypothesis as well as a research and alternative hypothesis in words. So as you formulate your hypothesis, Here are some criteria to ensure that you write an acceptable one. And this is taken from Bartos 1992. A well-written hypothesis states the expected relationship between the two variables. It's testable, the hypothesis is stated simply and concisely, and finally, the hypothesis is founded in the problem statement and supported by the research. It aligns with the research question. We're going to take a look at how to do this. Let's take a look at a hypothesis that was proposed by a beginning researcher. Now here you'll see that the hypothesis, specifically the null hypothesis, was derived from the research question, and we're going to assume in this case that it was derived from the empirical literature and the purpose statement. So, the researcher proposes two null hypotheses. We're going to take a look at the first one. The null hypothesis states the media-rich technology education will not be effective for students. Now we're going to take a look at evaluating this using the criteria for an acceptable or well-written hypothesis. Here we see the criteria for writing an acceptable hypothesis. First of all, does this hypothesis state the expected relationship between variables? Well, we could say, yeah, probably. Here we see the researcher expects a relationship to exist between a media-rich technology education and effectiveness. However, you've probably already thought, what in the world do these two variables or these two concepts mean? The variables are not clearly defined. Thus, what we would find is it would be really difficult to test them. First of all, what is meant by effectiveness? Second of all, what exactly is media-rich technology education? And finally, who are these students? Are they primary students, secondary students, university students? These terms, in order to be testable, need to be stated more simply, more concisely, more clearly. They need to be operationally defined in order for this hypothesis to be testable. Remember, an operational definition is simply a clear, concise definition of how a variable is going to be measured or observed in the research study. This is different from a dictionary definition. For example, let's look at the word effectiveness. If we were to look up the word effectiveness in the dictionary, we would find the following definition: an adequate the following definition: producing an intended or expected result, to accomplish a purpose, or adequately accomplishing a purpose. Now, this dictionary definition is not precise enough for the purpose of research. So it's we can say really it's too general. What we need is a more exact indicator of effectiveness. This may be, for example, a score on some type of validated achievement test. Let's say we were looking specifically here at math. We would want to look for a validated math achievement test. Or we may want to look, let's say effectiveness was being measured by some type of attitude toward math. We may want to look for a validated attitudinal survey, such as the attitudes toward math inventory. That would be how we would more specifically or operationally define the word effectiveness. Next is the word media-rich technology education. This may be more precisely defined as the Math 2.0 program, and something then explained in the research study. And let's say that students can be more precisely defined as undergraduate students enrolled in an online statistics course. In an online statistics course. So, understanding these operational definitions, we can then revise the hypothesis and make it more testable, and also state it more simply and concisely. And then finally, the other two criteria: is the hypothesis grounded in the problem statement and the research and the research question? We already established this and said yes, it was. So let's take a look at a more or a better or well-written hypothesis. Now let's take a look at restating the null hypothesis using what we just discussed. That is, let's restate the null hypothesis using the operational definitions in order to make our hypothesis more clear, more concise, and actually testable. There's two ways you could restate it. First of all, you could state that the Math 2.0 program will not statistically significantly affect online undergraduate students' attitudes toward math as measured by the Attitudes Toward Mathematics Inventory. Another way to state it is there will be no statistically significant difference in the mean final exam scores of online undergraduate students who participate in the Math 2.0 program as opposed to the online undergraduate students who participate in a traditional statistics course. Now, you can see that there's a difference in the dependent variables here, but you'll also see another difference. In the first one, we know that the researcher is examining the Math 2.0 program. In the second one, we can clearly see the levels or groups of the independent variable that the researcher is examining. So ultimately, I usually prefer to state null hypotheses in the second way, so you can clearly see not only the population being studied and the dependent variable being studied, but also the groups or the levels of the independent variable being studied. Now you'll note in the two well-written or acceptable hypotheses that we just looked at, we use the term significant or statistically significant, or not statistically significant and no significance. Remember, when you're testing null hypotheses or you're testing hypotheses, you're examining to see not only if there is a difference, but a statistically significant one. You're observing whether the difference was due to chance or the intervention. Therefore, when you're writing your null hypotheses, as well as your research and alternative hypotheses, it's important to use the term null statistically significant or statistically significant, or no significance or not significant or significant, rather than just using the term difference, because you are looking for a statistically significant difference. Now, we've talked a lot about writing a well-written hypothesis. We talked about using precise terminology that implies the type of design and analysis that we have planned for our research study. We talked about using operational definitions to ensure that our hypotheses are stated clearly, concisely, and are testable. Now, believe it or not, we are not done talking about writing hypotheses. Remember, we're still on step 1 of hypothesis testing, stating the null and research hypothesis. There's one more thing we need to talk about before we move on, and that is the rules about the number of hypotheses needed for each research question. Now, every research question needs to have at least one corresponding null hypothesis and one corresponding research hypothesis. However, because of the choice of analysis for a research study, sometimes more than one hypothesis is needed, more than one research hypothesis and more than one null hypothesis is needed for one question. The number of hypotheses is dependent upon the analysis chosen, but the number of hypotheses can be determined based upon the number of variables under investigation in the study. Let's take a look at the first rule, and this one's pretty simple. If you're conducting research in which differences between groups are examined and you have one independent variable and one dependent variable, then one research question is needed with one corresponding null hypothesis and one corresponding research hypothesis, because only one main effect is studied. In a correlational study, if you have two variables of interest, you're just looking at the relationship between two variables, then you only need to write one null hypothesis and one research hypothesis to correspond with your research question. Let's take a look at this. Here we see a researcher who's interested in understanding if there is a difference in students' sense of community scores based on the type of course in which they participate. Since here the researcher is interested in differences in one dependent variable, which is sense of community, based on one independent variable, which is type of course, and this independent variable may have two groups, online and residential, or it may have three groups, online, residential, and let's say hybrid. But since there's one independent variable and one dependent variable in this research question, then the researcher only needs to pose one corresponding research or alternative hypothesis and one null hypothesis. Here we see an example of the null hypothesis. The null hypothesis states there is no statistically significant difference in sense of community among undergraduate students based on type of course. This hypothesis would examine one main effect. Now let's take a look at a correlational example. Here we see, instead of being interested in the difference between groups, the researcher is interested in the relationship between variables and plans to conduct a correlational study. Specifically, the researcher is interested in if there is a statistically significant relationship between undergraduate students' perceived learning scores and their sense of community. Since the research question has two variables of interest, perceived learning and sense of community, only one null hypothesis is needed and one research hypothesis. And here you see an example null hypothesis. There is no statistically significant relationship between undergraduate students' perceived learning and their sense of community. Now let's take a look at the second rule. The second rule is this: if you have two independent variables and one dependent variable, you test three null hypotheses. You test two main effect null hypotheses, one for each of your independent variables, and an interaction hypothesis, which is referred to as a first order interaction, the interaction between two variables. So if your research question has two independent and one dependent variables, you state three null hypotheses and you state three alternative hypotheses. Let's take a look at this rule. Here in this example, we see that the researcher is still interested in examining student sense of community. And he's still interested in examining student sense of community based on the type of course in which they're enrolled. However, he's also interested in another independent variable, gender. So he's interested in how sense of community differs based on whether or what type of course the student's taking as well as their gender. So he poses the question, will there be a statistically significant difference in students' sense of community scores based on the type of course they take and their gender? So here, since the researcher has one dependent variable, sense of community, and two independent variables, type of course and gender, then the researcher needs to pose three separate null hypotheses. He'll also have to state three separate alternative hypotheses. Let's take a look at these null hypotheses, and they're stated here for you. First of all, the researcher is going to have to pose a main effect hypothesis for the first factor or independent variable. So the first one states this: there is no statistically significant difference in sense of community among students based on their type of course they take, whether it be online or residential. The researcher also needs to state a main effect hypothesis for the second independent variable or factor. This null hypothesis would state there's no statistically significant difference in sense of community among students based on their gender, whether they're male or female. The researcher would also need to state an interaction hypothesis, which considers both independent variables. And this would be stated like this: there is no statistically significant difference in sense of community among students based on the type of course they take, while their gender remains constant, and based on gender. So here you see an example of how to write hypotheses when you have one dependent variable and two independent variables. Now, what if in our research scenario the researcher wants to also look at ethnicity and add a third independent variable? Well, if you have three independent variables and one dependent variable, you test 7 null hypotheses. Now, why 7 null hypotheses? Well, this time you would have 3 main effect null hypotheses, in this case one for gender, one for ethnicity, and one for type of course. 3 first order interaction hypotheses, so hypotheses that look at the interaction between each of those variables, between gender and ethnicity, gender and type of online course, and then ethnicity and type of online course. And then finally, a second order interaction which involves all 3 independent variables. So if you have 3 independent variables and 1 dependent variable, you would need to plan to test 7 null hypotheses. So you'd state 7 null hypotheses and 7 research or alternative hypotheses. So each time you increase the number of independent variables, you increase your number of null and research hypotheses. You increase both the main effect hypotheses as well as the interaction hypotheses. So we've looked at independent variables. Now let's take a look at increasing the number of dependent variables. If you plan to examine 2 or more related dependent variables, then you need to state a hypothesis, a null hypothesis for the linear combination of the variables as well as each variable separately. And then you would also need to state research hypotheses for the linear combination of the variables as well as for each variable separately. Now, note I said here correlated or related dependent variables. If dependent variables are significantly related, then they need to be analyzed together in order to control for possible error. If, however, they're not related, then you would just consider them separately and you'd have, let's say, 1 independent variable and 1 dependent variable. So you go back to 1 hypothesis. Now, the same logic holds true for correlational studies. If you have 2 or more variables of interest or 2 or more predictors, you need to state hypotheses for the linear combination of the variables as well as each variable separately. Let's go ahead and now take a look at this. Let's say that the researcher, in the example that we've been considering, wants to not only consider sense of community, but he wants to look at the subscales for community, which are learning community and connectedness. And through a literature review, he determines that these two variables are related. So he knows that they need to be considered together in his research question and ultimately his hypotheses and then analysis. So he poses the question, will there be a statistically significant difference in learning community and connectedness among undergraduate students based on the type of course in which they're enrolled? So here we see that he has the independent variable, again, of type of course, and it has two levels or two groups, and he has two dependent variables, like we said, learning community and connectedness. So based on the rule that we just went over, we know that he needs to have 3 null hypotheses and 3 research or alternative hypotheses, because he needs to consider, remember, the linear combination of the variables, as well as he needs to consider in his hypotheses each variable separately. And since he has 2 dependent variables that are related, he needs one hypothesis for both of them and one for each individually. So these then become his null hypotheses. First of all, he looks at the linear combination and he says there will be no statistically significant difference in the linear combination of learning community and connectedness among undergraduate students based on their type of course. This considers both of the variables. Then he looks at each individually. There will be no statistically significant difference in learning community among undergraduate students based on their type of course. And then there will be no statistically significant difference in connectedness among undergraduate students based on their type of course. Now, what would happen if, let's say, sense of community had 3 subscales and not just 2? How many null hypotheses and alternative hypotheses would the researcher need in this case? If you're thinking 4 of each, you're correct. He needs 4 null hypotheses and 4 research hypotheses, because he'll need 1 hypothesis to consider the linear combination of the variables, and then 1 for each of the 3 individually. Now let's take a look at this rule, or looking at a correlational study. Here we see the researcher wants to know if students' sense of community scores can predict perceived learning and course points. So the researcher is interested in examining the relationship between 1 criterion variable, sense of community, and 2 predictor variables, perceived learning and course points. Therefore, based on the rule that we discussed, the researcher needs 3 alternative hypotheses and 3 null hypotheses. And the 3 null hypotheses are listed here. First, we see a null hypothesis for the combination of the 2 predictor variables. It states online undergraduate students' sense of community does not statistically significantly predict their perceived learning and course points. Then we see a hypothesis for each of the predictors individually, first for perceived learning and then for course points. So this provides an example. We're going to look at one more rule before we move on to the next step in hypothesis testing. The final rule for writing a hypothesis or hypotheses is this. When you have a control variable, this needs to be reflected in the hypothesis or hypotheses. For example, let's say that the researcher is interested in knowing if there's a difference in sense of community among students based on the type of course in which they're enrolled, either online or residential. But he also wants to control for one other variable, and that's gender. Here you can see an example null hypothesis that considers the control variable or the covariate. It states this: there will be no statistically significant difference in sense of community among students based on type of course, online or residential, while controlling for students' gender. That while controlling for students' gender reflects the control variable. So now we've talked about how to write good null hypotheses and good alternative or research hypotheses. We talked about writing in precise language, using correct terminology. We talked about using operational definitions in order to make a hypothesis testable. And then finally we talked about the rules for the number of null and research hypotheses that are needed for each research question. We're now going to move on to step 2 of hypothesis testing. As we've been talking about hypotheses and hypothesis testing for quite a while now, we're going to look at steps 2 through 4 of hypothesis testing, as well as type 1 and type 2 error in the next tutorial. So this concludes this tutorial for now.